proportion of people having a particular medical condition is 1 in 100,000. Random sample of 2,500 is obtained. The number of people in the sample having this condition is denoted by X. So N is 2,500, and the probability of success is 1 in 100,000. The number of people having the condition is denoted by X. So you have N, you have P. This should be a binomial distribution. Part 1, state with a justification a suitable approximating distribution for X, giving values of any parameter. N is 2,500. This is large. So N is large. And now let's check N times P. So we have 2,500 times 1 over 100,000. And that gives us 0.025. That is less than 5. So when N is large and NP is less than 5, which is small, then we say that X can be approximated by a Poisson distribution with lambda or the mean to be NP, which is 0.025. That would give us the approximating distribution. Part 2, we need to calculate the probability that X is greater than 0. The values of X is the number having the condition denoted. So X will be 0, 1, 2 until 2,500. So for probability X greater than 0, we need to find the probability X is greater than or equals to 1. Yeah, we are not doing that. That will give us 1 minus probability X equals 0. Total probability is 1. This is what we want. 0 is what we do not want. We have 1 minus probability X equals 0. And since X follows a Poisson distribution, we have e to the negative lambda, e to the negative 0.025, lambda to the 0.025 to the 0 over 0 factorial. Okay, for all these here, you see that this has a value of 1, that has a value of 1. The only thing that we are evaluating is this e to the negative 0.025 using your calculator and subtract from 1. That will give us 0.0247 to 3 significant figures. Part B, the percentage of people having a different medical condition is thought to be 30%. A researcher suspects that the true percentage is less than 30%. The keyword is less than. In a medical trial, a random sample of 28 people was selected, and 4 were found to have this condition. We have N equals 28, and X here is 4. Out of 28, 4 has this medical condition. The null hypothesis in this case, we are asked to test the researcher's suspicion at the 2% significance level. So alpha is 0.02. The established percentage is 30%. So the null hypothesis states that P is 0.3 against the alternative that P, because of the word less than, so P must be less than 0.3. If the null hypothesis is true, we always assume that the null is true, then X follows a binomial distribution with N equals 28 and P equals 0.3. We are going to use this established binomial distribution to find the probability, the tail probability, P is less than 0.3, we have X equals 4. That is what we found. So we want to find the tail probability using what we know. We need to find the probability that X is less than or equals to 4. And then we compare this against alpha, which is 0.02. If this probability is less than 0.02, then we have a rare condition. We have a rare event, meaning that the null hypothesis is no longer true and it can be rejected. That is what we are testing here. So we want to see whether 4 is a rare event or not out of 28. We want to find the probability that X is less than or equals to 4. Then this will give us probability X equals 0 plus probability X equals 1. This is painful. 3, and finally probability X equals 4. And now we use the PDF for binomial. That is 20C0, 0.3 to the 0, 0.7 to the 28, 28C1, 0.3 to the 1. Yeah, we don't write the 1. This is 27. Okay, we just compute all these using our calculator, and the tail probability is 0.0474. So probability X less than or equals 4 is 0.0474. Now we compare this with 0.02. Upon comparison, this is greater than 0.02. So if it is greater than 0.02, we do not reject the null hypothesis. That is the decision. And then you need to write a conclusion. So the conclusion states that there is not enough evidence to indicate that the alternative hypothesis is true. You always conclude the alternative hypothesis. So there is not enough evidence to conclude that the true percentage is less than 0.3. That is how you write down your conclusion.